My name is Brett Smithley, and the title of my research paper was Mathematics Instruction and the Importance of Short and Long-Term Memory. The math content area is unique because learning mathematics is a continuous process that happens throughout our entire adolescent education. In primary schools, we're going to learn the foundational mathematics skills that are used as building blocks for the higher level or more complex math that's taught at the secondary level. In order to perform well at the secondary level, we need to be able to retain the information that we're taught in earlier years. And in that system, the information is processed using three different areas of our memory. First is a sensory immediate memory where we're taking information from our environment and then either immediately forgetting it or pushing it on to the working memory. And the working memory is where we're going to process that information, encode it, and transfer it to long-term memory. The criteria needed to put something into long-term memory is providing sense and meaning for that piece of information. And since in education, we're just not learning something for one-time use, we also need to be able to recall that information for future use. And then once information is recalled, we're putting it back into our working memory, which is essentially the workhorse for learning. Working memory is made up of four different parts. You have the central executive, which deals with all the cognitive abilities located in the prefrontal cortex. It's controlling the use and encoding of the information that you receive. It's dealing with the phonological loop, the visuospatial short-term memory, and episodic buffer. So it takes all this information, and then once you provide sense and meaning, then it's going to put it back into our long-term memory. And the last thing that's important is if we're solving basic math problems, you're dealing with factual memory and procedural memory. So you're understanding your times tables, and then you're able to easily do the procedure such as multiplication or division. Where it gets complicated is when we're dealing with more complex math problems because it's more taxing on our working memory capacity, which is limited. So while you're recalling information and trying to solve the problem, you may lose information before you're able to find the solution for that problem. So maximizing the capacity of our working memory is an important part of learning mathematics. The areas of the brain involved in dealing with memory storage and processing is first and foremost the thalamus. That's where we're receiving all sensory input. Once we receive that input, it's pushed into working memory, which is made up of three parts of our brain. You have the frontal lobe, the temporal lobe, and the occipital lobes. And as stated before, the prefrontal cortex and the frontal lobe is going to house the central executive, which is going to be the primary source of processing the information that's going to be transferred into long-term storage. The long-term storage is handled by the hippocampus. And then another part in the central brain that's going to help with long-term memory storage is the cerebrum and cerebellum. The cerebellum helps working memory function more efficiently because it functions without conscious attention to detail. Therefore, it frees up much needed working memory capacity for processing new information we're strengthening the neuron pathways to stored information. The impact on learning, you have the learning process where we're receiving new information and accessing prior knowledge. So when we access prior knowledge, we're retrieving information from our long-term memory. And that's done in one of two ways. When you retrieve information, it's either through recognition or recall. Recognition is just merely matching sensory input with something stored in our long-term memory. When we recall information, it's much more difficult because in order to retrieve that information, we're using a series of cues and retrieve from multiple locations in our long-term memory. So retrieval is more difficult than recognition. Then we have the new information, such as the content we're learning in the classroom. And what we need to do is marry that information. We need to take the new information and encode it with the prior knowledge and then put it back into long-term memory. Now, as Sousa states, the more connections that students can make between past learning and new learning, the more likely that they're able to make sense and meaning, thus retain that information. Classroom applications. First and foremost, from learning mathematics, you have the Common Core State Standards for Mathematics, as well as learning progressions. It's the structure, the way that we teach mathematics in school that is aligned and helps students learn and use prior learning to be successful in later years in education. The learning progressions focus on 6 major content strands that have specific targets that get progressively more complex across grade spans. So these learning targets, they're also aligned with the Common Core State Standards, and they systematically introduce new content to students starting in primary school all the way through secondary education. So these are the building blocks of using prior knowledge and encoding with new information that's going to help students retain that math knowledge as they move through school. Another way to do a specific content area is spiraling curriculum. Spiraling curriculum is spacing of information that causes difficulty in learning, which also enhance retention because you're introducing a content early in a subject and then you're revisiting it later. So within that time between both learning episodes, you're causing your brain to retrieve that information. So you get practice in retrieving memories that build stronger neural pathways to the information. Then you have the testing effect. The testing effect in a particular subject is the spacing of forced retrieval through the use of formative testing. So you introduce a topic and then you're testing on that topic weeks later. You're forcing retrieval, which makes retention better. The next area we have is chunking. You're chunking information to help the working memory capacity where you're organizing information either through patterns or categories that allows you to put more information into your working memory that can be recognized and used when solving math problems. And then the last thing is our classroom environment. By providing a safe and supportive environment, you're allowing the students to focus on learning, which allows them to concentrate and use their working memory more effectively. And also with that, you're dealing with learning episodes. So it's an important aspect of managing memory capacity where you're using that time effectively to teach new information. You're aware of the downtime, and then you're closing in those. You're using closing activities to reinforce what was introduced early on in the class.